a typical related rates problem. You've got gravel being dumped onto this pile of gravel at a constant rate of 30 cubic feet per minute. That's the same thing as telling you that the derivative of volume with respect to time is 30 cubic feet per minute. And we want to find out how fast this height is changing when the height is 24. And that's the same as asking us to find dH dt. Now we've got two variables on the right here, two independent variables, r and h. We'd like to get the volume in terms of just the variable h, and they tell us that h is always equal to this base diameter, d, but the diameter is twice the radius. So it must be true that the radius is always half the height. So we can rewrite this formula in volume in terms of h only. R is h over 2. So we have to square that. And I'm mixing uppercase and lowercase h's there. So in the end, if we square h over 2, we get h squared in the numerator times this h, and we get 4 in the denominator. And 1/3 times that 1/4 is 1/12 pi h cubed. So what we like to do is take the derivative of that equation for every variable with respect to t. We're assuming that the volume and the height are changing with respect to t. So the derivative of volume with respect to t equals dv dt. Pi is just a constant, so I'm going to multiply 3 times 1/12 pi and get 1/4 pi. Reduce the exponent by 1. And then I have to multiply by the derivative of the inside. This h is depending on t. So it's some function of t, we just don't know what it looks like. So the derivative of h with respect to t. So there's our formula that relates the rate of change of the volume with the rate of change of the height. We know that this is what we want to find, dH dt. So when h is 24, we know that dV dt, I'll move up here, is 30 cubic feet per minute. And a lot of times we don't carry the units around, but it's instructive to see how this dH dt turns into feet per minute. 1/4 pi h squared would be 24 squared, and dH dt. To solve for dH dt, I have to multiply both sides of the equation by the reciprocal of this numerical coefficient. So I'll start by multiplying both sides by 4. By the way, when I squared this height, I got feet squared. I didn't put the units over there. And then I'm going to divide by 24 squared and pi. I'll write 24 squared as 24 times 24. There's the pi. The units that I carried over are actually feet squared. And that's dH dt. That's how fast the height of the pile is changing at the time when t equals 24. 24 goes into 120, 5 times? So, and feet squared goes into feet cubed and just leaves feet. So I've got 5 over 24 pi feet per minute. That's how fast the height of that pile is changing when the height is 24 and the volume is increasing at a constant rate of 30 cubic feet per minute. There you go. Hope that helped. Post a comment if you have any questions.